Welcome to lesson 7.1, Drawing Triangles for Advanced Geometry. Now, chapter 7 is all going to be about different applications, relationships, usages of congruent triangles. We're also going to look a little bit at the idea of similar triangles, but mainly that idea of congruency among different triangles. Now, some of it will be a brief review of things that we touched on real briefly earlier this year, but now we're going to take some time to go more in depth. So the first thing we're looking at with drawing triangles are these different pieces of information, or the kind of the scenarios that you could be given. So if we're looking at these different pieces of information related to a triangle, one way that they may give you information is known as side, 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 where they give you all three sides of the triangle. In that condition, any other triangle with the same three sides would result in congruent triangles. So if you're given all three sides, any triangle with those same three sides would be congruent. Then we have angle, 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 where all three angles of the triangle are given, but no information about the sides. This results in not necessarily congruent triangles, but similar triangles. The reason that they could be similar but not congruent is we could have a triangle whose angles are 60, 60, 60, and sides are 4, 4, and 4. Or we could have sides of 12, 12, and 12. Same with anything else with similar triangles, angle, angle, angle. The three angles are the same does not mean the side lengths will have to be the same. So that does not result in automatic congruent triangles. The next one we have is side, angle, side. This is when two sides are given and the included angle. So what they mean by the included angle is those two sides create the vertex of that angle. And you can look down at example 1a to see an example of that. Anytime we're given side, angle, side, where you know the two sides and the included angle, that would always result in congruent triangles being created. The next one we have is side, side, angle, when two sides and the non-included angle are given. In this case, that does not have to result in congruent triangles. Then we have angle, side, angle. Two angles and the included side are given. So that would be like example 1b down below. And that will always result in congruent triangles. And the last type of relationship we have here is angle, angle, side. So two angles, and then a non-included side. So angle, angle, side, that would be like example 1c below. That also always results in congruent triangles. So in the next few sections, we're going to go deeper into that idea of how these result in congruent triangles. For today's section, you just need to know these relationships and if they guarantee we'll have congruent or not congruent triangles. So example 1 just asks us to determine which of the above the markings on each triangle represent. So out of these above options right here, what markings did they give us? So in this case, we're not looking at the markings as being congruent, it's just information. So in A, they gave me a side 1, a sandwiched included angle, and then side 2, and the reason I call it sandwiched is it's in between or included between the two sides, so that would be side, angle, side. In B, we were given an angle, a side in the middle, and another angle, so that would be angle, side, angle. In C, we were given an angle, and a side, so that would go angle, angle, side. And in D, They gave us 3 sides, so that would just be side, side, side. The other task that you'll be given today is they will give you pieces of information and ask you to draw the triangle based on the given information. Then they will ask to determine if all other triangles with the same information would have to be congruent. And that's where you'd want to look back up here at this information on the right-hand side. But if we look at A, what they told us was they gave us angle A being 90 degrees and angle B being 28. So they gave us 2 angles and no side information. I'm going to come back to how to draw the triangle, but I drew it so I had a 90 degree and my 28. I know my third angle is 62, but looking up above, does angle, angle, angle always create congruent triangles? No, it does not, because they can be similar. So, not congruent to all other triangles with the same info. The sides could be a different length. If I'm looking at B, what they gave me was side AB, side BC, and then angle B. So after I drew it, I could see I had a side angle side relationship, so all the triangles would be congruent to that. Now, the most important part of this process is learning how to draw triangles based on the information. So what I'm going to do in just a second is flip my screen and walk you through example 2A and B on the process or steps I use to draw those. And then also with this lesson, I will include a couple extra videos that show you how to construct or draw triangles based on different information. Remember, with today's practice problems, the whole purpose is just to get practice with these approaches. There's a few different ways to do these, so if you don't like my approach or the videos I share with you, I encourage you to look online, find some other approach that works the best for you. So I'm going to quickly flip over to my .cam here and then cover the process for drawing A and B. A little bit. All right, so for drawing triangle A, what they gave us for information was that angle A was 90 degrees. So I know angle A was 90 degrees, and I know angle B had to be 28 degrees. So to draw this triangle, the first step is just to give us a line segment, and we can title that A and B. Now, if you're using graph paper, makes things a little bit easier to line stuff up, but doesn't have to be perfect. So I'm not going to perfectly line mine up on the squares. Just need to draw a line segment A and B. So I'm just going to label that AB. Now, what I know is that angle A had to be 90 and B had to be 28. Nothing about these side lengths. So what I'm going to do for this problem is I'm going to take my protractor, set the center point at A, and line up the bottom with B. Then what I want to do is come over to where A is, go up to my 90 degree point, and I'm going to put a dot there. Then I'll come back down to A, line it up with that dot, and I'm just going to draw in my construction side there to give me my 90 degree angle. Then what I want to do is come over to B. From B, I also want to put my protractor at B, line up the bottom line along AB, and then we want to measure where 28 would be. So 28 would be right about there. Then we come from B, line it up with that mark for 28, and draw in our segment. Where those two lines cross has now created point C. So I have my 90 degree, I have my 28 degree, and then by default, if I'd come in and measure this one out, that is going to give me my final angle that is missing, which would be my 62 degrees. So in that case, this one then would be 62 degrees. So that is how you would want to draw a triangle given just the angles. Now, if we look at part B, in part B, what they told us was side AB is 2.5 inches. Side BC is 1.5 inches. And then angle B is 30 degrees. So for this one, what I need to do is start with either AB or BC. Now I'm going to start with AB and give myself my segment that is 2.5 inches long. Now for the size of this, I'm going to want to give myself a little bit of room. And I'm going to draw in my segment AB. So now I have AB that is 2.5 inches long. Then I know BC has to be 1.5 inches, and I know angle B has to be 30 degrees. So what I'm going to do is go to angle B, put my protractor at B, line up the bottom with A, and I'm going to come and mark my 30 degree point. So 30 degrees would be right about here. Then I'm going to take my segment from B and draw it through that 30 degree line. Now I know C has to be somewhere along that line. What I need to figure out is where, which this tells me it has to be 1.5 inches. So I would take my ruler, measure 1.5 inches along that segment, and then put a dot there for C, go back in, and then connect A with C. And now we have our triangle where BC is 1.5 and angle B is 30 degrees. So there's a few different ways to do these, and with this instructional video, I'll also attach a few other short videos showing you how to do constructions based on different information. If you're struggling with that approach, let me know during office hours and I can help you out.